Welcome to breadboarding. This is the fourth video in the series of the breadboard video controller. In this video we're going to be carrying out step 3, and that's installing the 4K of dual port video RAM. This will allow us to do a 2-color 25 by 80 or 30 by 80 VGA display. So you can see here, the previous one we added the RAM character generator, and by the end of this video we should have a fully functioning video display, even though it's only able to do two hard-coded colors. And then in the future videos we'll be enhancing this and making it able to do full VGA graphics. So if you have a look at the block diagram that we had carried over from last time, so this was the block diagram we had last time with the cathode ray tube controller, our character RAM, and this was being fed at the time by just some address signals generated by the cathode ray tube controller, and we were just using that to substitute the 0 to 255 character values feeding into here. But what we're going to do now is to add in our dual port video RAM. So we're going to be wiring this into the main system address and data bus, just like the character RAM, and in fact we'll be just using a ribbon cable to extend the wires which are plugged in on this chip over onto the opposite side of this chip. The only thing that needs to be different is the chip enable signal will be different between the two. And then the output of the video RAM, so the data output will then be feeding into the character RAM to choose which character we want. Once we've installed the video RAM, then we should be able to use it just like a normal VGA display with a limited set of colours. So we have a look at our KiCad diagram. This is the character RAM we installed last time, and we're just going to be plugging in this chip here, which goes right beside it. The main thing that we're going to be doing is putting in a ribbon cable from the lines connected to all these pins here over to this side, because this side's also then going off to the system bus. The only thing that will need to be different is the chip enable. So chip enable will be Y0 in this case, where it says Y2 over on this side. Other than that, all the other signals will be the same. And then where we had the MA0 to MA7 address lines from the CRTC, so we were taking them from over here, we're now going to be plugging those lines into the address lines of our video RAM, and then the data lines 0 to 7 here are going to be driving the higher address lines over on the video RAM. So the bottom 4 lines determine the row of the raster image of the character, and then the top 8 lines determine the character value itself. And then the wiring up and all here is exactly the same. So it shouldn't take very long. Hopefully once we've plugged this in, change the wiring here and move the ribbon cables to here and here, it won't take very long. We're going to continue to use ribbon cables because we're going to be swapping out this chip for some larger spec memory. However, it's not dual ported, so it'll need a little bit more logic chips to multiplex and buffer the various signals and things. And we'll be doing that in some future videos. So here's our top-down view. The only difference from the last video is I've already extended the data bus here. So these are the data bus signals coming from over here, and also the read-write signal. And all I have done already, since it was a bit boring me cutting wires and things on video, is I've put the small links in here. These are 3-hole sort of jumpers, and I've extended the data bus and the read-write signals along this bit of breadboard. So I've got the second RAM chip here. These are the memory address lines from the CRTC controller, so we're just going to unplug these. Now, I did wire these up so that I could fit this in down the bottom here, and yes, we don't have a lot of space there. So in fact, we just have enough space to plug that in. There's going to be a connector going from here to here, so we probably need a little bit more space down here to allow the data lines to go up there and to allow these signals to come in. So I think we'll have the 2 holes on that side and the 3 holes on that side. Then all we need to do is to wire in the power. So ground is a relatively short one, although it has to go over a diagonal. So ground goes here. And then VCC okay, so we've got those there. So what I'm going to do now is I'll just speed up this. I'm going to be plugging in the memory address lines down here, wiring in the data lines here over to the address lines over here, and then we'll have a ribbon cable to go over there to there. So this is the printed out diagram we've got. So apart from the changes to the chip enable signal versus the output enable signal, then we just need to wire up the various read write and chip enable signals, and then we're going to do the memory address from the CRTC, and then we'll wire in these data outputs to the address lines in here. So just going to wire in the chip enable, and the read signal is always going to be set to read on this side of the video RAM. And now we need to hook in the address signals on the character RAM to go to the output of the video RAM. So the data values in the video RAM will be our character values, and that will then choose the block of addresses on the character RAM that we're going to be using, and obviously the row address signals will choose which row of the character is displayed at a particular point in time. So we'll just check those off the diagram. Now we're going to connect all the memory address lines from the CRTC chip. So that's the lines coming down here. We're not going to be using all the lines for the moment because we only have 4K of RAM here. So we tied up out of the way some of the ones we're not using. Now we're taking the system bus read, write, address and data signals from over on the right hand side there, and we're going to then plug those into the left hand side of the video RAM chip. So these are a little fiddly to put in, particularly the larger the number of connectors, the wires in the connector, it tends to be a little fiddly, but sometimes splitting the connector down the middle just gives you a little bit more freedom. And in fact, in this case, the data signals are crossed over in the middle, and I'll talk about that in a second. And there's one chip enable signal then we have to remember to put in. We're just going to put it at the top there. There we go. So that chip enable signal's in there. So we've done the crossover of the data lines. Now we just need to put the chip select signal in. So this comes from the address decoder on the Y0 line, and we're just going to plug that in. So this is looking a little messy now, but it will get tidied up in future videos when we put in an extra board here and we're going to wire in things a bit more permanently. This loop here, well, I think will still stay, just because to get this number of cables over the board here is going to be very messy, but a lot of these other ones we're going to wire up in a sort of, rather than using jumper cables, we're going to use custom fitted wires. So the only thing we had to be aware of here is that the order of the data pins on the right hand side of the chip goes from 7, 6, 5, 4, 3, 2, 1 down to 0 at the end of the chip, but on the left hand side the end of the chip is at 7, so we just have to be aware that 0 needs to go to the opposite side. So there's a bit of a cross in this cable, as we have a purple on this end here goes to the purple over here, so it's a bit of a cross. So these are the sort of things that you need to keep an eye out for. Now the only problem with these sorts of cables is they sometimes do lift out over a period of time, so we do need to make sure they're all pushed down. So the advantage of custom fit wires is that you really, once they're in, they generally don't move. So that should be it. We've done the hardware now. The only thing we're going to need to do now is to update the software. So I do have some test programs from the first generation board I did. What I'm going to do is to modify that to work with the memory addresses and things for the new NanoComp, and then we're going to load those down onto the board, load the character set values into the character RAM, and then see whether or not we can get a display running. Okay, so this is the display now that we've downloaded our test program. We've run it, but we haven't actually loaded the VGA font data down into the character RAM. So I'm just going to load that. We should see as we load that the display will change. There we go, and we can now see that our test pattern, you can see that we're slightly shifted over, so things starting a little bit at the about half a character over here, and we're not quite got the whole character on the other side over here, so we're kind of missing out on the line numbers there. But you can see down here we've got 1 line 2 3 all the way down to 30 down the bottom there. So that's the first version. That's pretty good. Now we're just going to run an updated version of the program that now prints out the character set as well. So hopefully that has come out okay. So that looks pretty good. So our test program seems to be working fine, and we're able to print out pretty much all of the character set. What we're going to need to do in the next video, we're going to be putting in some delays and flip-flops to adjust the timing signals so we can move things around. So we're going to do a bit of playing around to see if we can get the image to be centralized and to sort out some of these sort of half character adjustments that we need to make. But that shows we've got our video RAM working and our character RAM working, and the next step of the video will be to add the cursor and to adjust the timing and the display enable signals. In particular, display enable will be one of the things causing the picture to be shifted over like this. So thanks for watching. If you don't want to miss out on future videos, please hit subscribe, and if you can hit like as well if you found it interesting. Thanks for watching.